Okay, here we go with section 4.3. So we're hopping right back into it with what we did previously. There's a little bit of extra stuff to the quadratic ones because we have to complete the square on some of these to get them back to the vertex form. So the vertex form of a quadratic equation is this. It's like our circle here with our H on the outside. K is just going to represent up and down though, and H represents left and right. So when we do these, since this is x minus 4, just like before with our transformations, this doesn't mean left 4, it is right, and then 4 units. So here we have x squared plus 1. We don't have anything in the parentheses with our x, so this is just representing up 1. And then that one's left, down, and right. Here we have negative x squared subtract 1, so this is going to be reflected. And then that subtract 1 is down 1. So we're looking for the one that's upside down and down 1. This one is just down 1. I guess I could write these on here. I'm trying to decide if I can make it smaller, because so this graph right here is the normal x squared shifted down 1. This is negative x squared because it's upside down, but it has been moved up 1. This is a negative x squared because it's facing down, but it has been moved right 1, so it's going to be, why are you not? Negative x minus 1 squared. This is our positive one that's been shifted right 1, so it is squared. This is our answer. So this is negative x squared minus 1. This is our negative x plus 1 squared. This graph would be the positive x plus 1 squared because it's just left 1. And this graph is our positive x squared shifted up 1. That's a lot, but reflected and down 1. If you can look at that and tell me each of those and be able to do it though, you know what you're doing. So if you print that out and practice with it, you'd be off, like you'd be in good shape. Okay, here we have x squared subtract 2x plus 1. This graph right here, this is where we practice completing our squares because this is where we're converting from our quadratic equation to this vertex form. So from standard form to the vertex form. So the first step you need to do, I'm going to make an extra video of just completing this square. So we set it equal to 0. And if there's a constant with this, we move our constant to the other side. Not all of them will have constants, and that's okay. So we have negative 1 equals x squared subtract 2x. So we've set up our quadratic equation now to be able to solve to complete our square. I say we're completing our square because when we complete our square, we end up with this part. So we complete the square. Now you take your center term and divide it by 2. So I'm going to have negative 2 divided by 2 to get negative 1. Then you take whatever that is and you square it. So we're going to square our negative 1 to get 1. And whatever that value is, you would add it to both sides of this. So let's make sure that's we added this here and here. Now then I can rewrite this equation. 1 plus negative 1 is going to give us 0. Where do I want to write that? And then whatever I have squared on both sides, so I have my x squared and this negative 1 squared, that is what completes our square. Then we move, if there was a number still here, we'd move this number to the other side since it's just 0, we don't have to, and we reset it as our function. Oof, that's ugly. Like how I wrote it, it's ugly, it's actually really pretty for our purposes. So this one, since it's subtract 1, this is just the graph of x squared to the right one. Right here. Okay. So here we have f of x equals x squared subtract 4x plus 5. So first let's set this up. So we're going to have 0 equals x squared subtract 4x plus 5. We move our constant to the other side. So now I have negative 5 equals x squared subtract 4x. Then we're going to have our spots where we add whatever completes our square to both sides. We're going to take our negative 4 here and divide by 2 to get negative 2. We square this, so negative 2 squared is positive 4. It's always going to be positive because if you square negative, it's positive. If you square positive, it's still positive. Now then, we combine here. So 4 plus a negative 5 is negative 1. And then whatever we have squared, so x squared and negative 2, so x subtract 2 squared. Because if I multiplied this out right here, this x minus 2, I'd end up with x subtract 4x plus 4. That's why we complete this square. Then this constant that's over here, we're going to add it back to this side. And voila, we are in vertex form. If I stop, I lose my spot in the calibration. So because we add the 1 to the other side. Now then we have this in vertex form, so we're going to go right 2 up 1. Right 2 up 1. Okay. This one, setting it up, 0 equals x squared plus 6x. It is set up, so we're going to go ahead and say whatever completes our squares, you still have to add it on both sides, even though there's not a constant that you moved over. So take your 6, divide by 2, which is 3, square whatever this number is, and that's going to give us a 9. So 9 would complete this. And now then, whatever is squared, we're going to have our x plus 3 squared. And if I multiplied that out, we would get x squared plus 6x plus 9, like if you did x plus 3 times x plus 3. 9 plus 0 here, so this equals 9. I hate how this looks. So rewrite it as your function. And then since this was a positive 9, it's subtract 9 when you move it over. One thing I want to say real quick. When you're looking at these, if this is positive, it's going to be plus 3. If it's subtract, like the last two, that's when it's subtract in here. So, and that's very important because that tells us if it's left or right. So since this one is plus 3, we're going left 3, down 9. Left 3, down 9. This one's left and this one's left. But that's down 6. This one's down 9. We're halfway there. Oh, this one is 4/3 stretch. It's greater than 1, so I'm calling it a stretch. Remember, it doesn't matter where you click on this for 3.5 and 4.3 because it makes you use this, when you go to type this in, you're gonna do 4 and then type backslash, because that's gonna pop up your fraction. So 4 backslash 3, because it's being multiplied, it's a stretch or compression, and the, it's 4/3. I don't know if yours was 2/3, you'd still type it there. Check. Graph the function x plus 4 squared, subtract 5 using y equals x squared. So plus 4 is going to be left 4 and then down 5. Can I move you over here? Okay. So graph of x squared, doesn't matter where you click because it's going to put it there. Vertical is up and down, so down 5, so that's -5. Okay, it looks like it's on like -6 over here, but it's on -5 there. And then left 4 is going to be negative, pop back, -4, -5. All right, this one we have to complete the square to be able to do it. So we have, I like that I have this space right here on this one. 0 equals x squared plus 4x plus 3. Move our constant first. So I have -3 equals x squared plus 4x. Now when we complete our square, we're going to have to add that value on both sides. So I'm going to have my middle term, 4 divided by 2. It's going to give us 2, and we square that to get 4. This term goes here and here. We take what we squared over here. Well, let's do it in order, left, right. So 4 plus -3 would be 1, equals then the two things we have squared here. We have x, and that's a positive 2 squared. Move everything to the same side. Let's see if I can write it over here without going crazy. F of x equals x plus 2 squared and minus 1. Okay, so now then, since we have it in vertex form, this is going to be left 2 down 1. Left 2 down 1. Get rid of the math, I guess. Okay. Doesn't matter where you click, and then left 2 would be -2 here. It's -3, -2, and then down 1. Okay. Close, save, left 2, down 1. Okay, so here we have -x squared subtract 2x. I know this graph is going to be reflected because it's a reflected graph. There's a negative in front of x squared. If there's a negative in front of x squared, we have to factor that out. So negative divided by a negative is a positive. Negative divided by a negative is a positive. And then we're going to complete our square still. So on this side, when I complete that square, since there's a negative that I factored out, I have to keep that negative on the other side as well. So we're going to do our 2 divided by 2, which gives us 1 squared, which is 1. Then we'll rewrite this. So now I have -1 equals negative, because that doesn't go away, my two things that are squared, x plus 1 squared. Now when I move this -1 over, I add it. So our final function, -x plus 1 squared plus 1. But our changes to this graph is going to be a reflect. Then since it's plus 1, that's left. And then the plus 1 on the outside is up. That's one thing I don't like, having to erase the work to be able to do it. Okay, when you go to do your reflection, it's a reflection about the x-axis. Let's get that back up here. So it flips it, and then we're gonna go left one. Did it do it? Is it just, I think it went to 2. Left one, and then up. Oh man. Oop. Left one, up one, reflect. I don't know why they gave us all those numbers. Oh. Now then, when you look at this one, be sure that you are grabbing the vertex point, this point, not the intercept, because they give you 2 points here. So our vertex point is 1, -4. Remember, these relate to our h and our k. So I'd put these in here, so I'm going to have y equals, and I don't need to put the y equals because we're using function notation, and they have the equal sign for me, so I don't need to put that. I'm going to have x subtract 1 squared plus, it'd be -4, so plus k, but it's -4, so ta-da. If the graph was upside down, I think the next one is, so I'll hold off on that. X minus 1 squared subtract 4. Yep. So this graph is reflected. So our vertex on this one is -2, 5. This is our h, this is our k. But you have to remember that this is reflected. So we can still use our h and k to put it in here. I'm going to have x subtract -2 squared plus 5. Now we have a negative that we put at the front. We don't distribute it or anything, we just leave it there. But don't put subtract a negative. I think the problem on the test is like this. I need to double check those.